Welcome everyone. I'm excited to kick off today's presentation on newer study designs. Today, we'll be focusing on adaptive study design. We'll explore what it is, how it works, and why it's becoming increasingly important in research. Over the next few slides, I'll walk you through the key concepts and some real-world applications. So let's get started. Let's talk about adaptive design. In clinical research, the gold standard has traditionally been the randomized controlled trial, or RCT. Now, while RCTs are incredibly valuable, they also come with some challenges. They can be quite expensive and sometimes ethically complicated. Plus, they can be too rigid to account for the messy, unpredictable nature of human biology and behavior. This is where non-conventional study designs come into play. They're often more creative and efficient, allowing us to answer specific questions that traditional methods might struggle with. Adaptive design, in particular, is a flexible approach that goes beyond the classic models. It allows us to modify aspects of the study as it progresses, tailoring the methodology to better fit real-world, complex conditions. By doing so, we can improve the relevance and applicability of our findings, making our research more aligned with actual clinical practice. This approach is especially important as we strive to find more innovative, efficient ways to generate meaningful evidence in healthcare. Unlike traditional fixed designs, adaptive designs give us the flexibility to make changes during the trial based on interim data. This means we can adjust the study without compromising its integrity. For example, if we see that a particular treatment isn't showing promising results, we can drop that arm altogether. Or, if the effect size is smaller than we initially expected, we can increase the sample size partway through to gather more reliable data. The main benefit here is efficiency. We're not wasting time or exposing participants to treatments that aren't working. Instead, we can make smarter, data-driven decisions that keep the study on track and maximize resources. This approach aligns with our overall goal of conducting smarter, more adaptable research. Let's talk about the core component of adaptive designs. These designs are governed by a strict protocol, meaning you can't just make sudden changes on the fly. Everything that can be adapted must be written down and agreed upon before the study even begins. This ensures transparency and helps maintain the integrity of the trial. Now, during the trial, we perform what's called interim analysis, basically periodic health checks on the data. These checks allow us to see how the study is progressing without waiting until the very end. Crucially, decisions during an adaptive trial are based on pre-specified rules, so no gut feelings or intuition come into play. For example, we might decide that if the drug proves to be 20% more effective than the placebo at month 6, we will stop enrolling participants in a specific group. These rules are all mathematically defined beforehand to keep the process objective. Finally, I want to highlight the regulatory aspect, especially in India. Approval for these types of studies is managed by the Drugs Controller General of India under the CDSCO, using Form CT04. Because adaptive designs involve making changes during the trial, regulators require strict pre-specification of all adaptation rules. This is to prevent errors like false positives or type I errors. It's also a good idea to consult with regulators early in the process, given the high level of scrutiny these designs attract. Let's take a closer look at some common types of adaptations in clinical trials. First up is sample size re-estimation. This involves adjusting the number of participants, either increasing or decreasing, to make sure our study has enough power to really detect a true effect. Essentially, it helps us confirm that our results are reliable and not due to chance. Next, we have dose finding. This process involves dropping doses that are either ineffective or too toxic. The goal here is to focus our resources on the most promising dose, which can improve patient safety and make the trial more efficient. Then there's enrichment. This means narrowing our focus to a specific subgroup of patients, such as those with a particular genetic marker. If we know the treatment only works for certain types of patients, this helps us target those who are most likely to benefit. Finally, early termination is a strategic decision to stop a trial early, either because it's unlikely to succeed, which we call futility, or because it's working so well that it would be unethical to keep giving placebo. This saves time, reduces costs, and most importantly, protects patients from unnecessary exposure. All of these adaptations are about making trials smarter and more adaptive, ultimately helping us get to effective treatments faster and more safely. Let's take a look at the merits of adaptive designs. They tend to be faster and more cost-effective, which is a huge advantage in clinical research. By being able to cut out losing strategies early on, we can bring effective treatments to patients much sooner, potentially saving lives. It's also more ethical because fewer patients are exposed to doses that might be ineffective or harmful. Now, turning to the demerits, one of the main challenges is that these methods can be mathematically complex. They involve advanced statistical techniques that require careful planning and understanding. Additionally, the statistical penalties for peeking at the data early, what we call the penalties, can be quite high, which means we need to be cautious about how we interpret early results. There's also the risk of introducing bias if the adaptation process isn't perfectly insulated from the researchers. This could unintentionally influence the outcomes, so rigorous controls are essential. Overall, while adaptive designs offer exciting benefits, they also come with complexities that we need to manage carefully. Thank you so much for listening. I really appreciate your time and attention throughout this presentation. If you haven't already, please consider subscribing to stay updated with future content. Your support helps us continue to share valuable insights and resources. Once again, thank you for being here, and I look forward to connecting with you in the next session.